Okay, hi everyone, and welcome to the second part of the lesson on using nesting to perform functions across multiple datasets in one go. This video picks up where we left off in the previous video that developed a function to perform the send slope across time series data and then tidy the output of the send slope to a single row that contained all of the statistical results of that test. What we're going to do now is essentially use that function across multiple data sets at once using map, which you should be familiar with by now, and nesting. So the very first thing, since I'm kind of picking up at a different time here, I'm going to make sure all of my packages are installed. I'm going to load back in my water quality object and then this low flow object. The other things that I'm going to need to run aren't necessarily this exploration that we did with the Dolores and calcium, but definitely want to load in that function that I created because we will be using that across all of our data sets. So to nest our data means that we'll be bundling each site parameter's time series data into its own data frame within a bigger data frame, or nested, if you will, within a larger data frame. Our first step towards nesting is to group our data set into the categories in which we want our data to be stored by. We want each of our site parameter combinations to be contained within their own nested data frame, right? So here I'm gonna write some code to group by our basin or site and water quality ion. So we're gonna start off with creating the object name. I'm just gonna call it low nest. I'm not very creative. And we're gonna start off with our low flow object. Use the pipe. Oh, right. So this is a bit of an annoying step that we're going to need to do. But as our data exists right now, we have this column called parameter. To ensure that other steps in the future actually work, we're going to need to rename this column to be something else. This is because when we start nesting, basically there's another object called parameter in, I believe, the model results. So we just need to essentially rename this column. Don't get too bogged down by this step, but to rename a column, the first thing you do is use rename, and then we're going to give it the name we want to change the column to. I'm going to just call it characteristic. And that's going to equal our currently named parameter column. Oh, and we don't need that. This is not a function, it's an object. Okay, so to get back on track here, as I said, the next thing that we need to do for nesting is identify what we want the nests to be grouped by. So we're going to use group by, and we want a unique nested data frame for every site parameter combination. So we're going to do characteristic and then basin, which is the column name that has our site names. And then you just use nest. So before I show you what this low nest object looks like, let's just review what the low flow object, the original object, looks like. Here we have a bunch of information for every site, parameter combo, and year. So as we scroll through here, you see like all of our data frames, if we were to have a data frame for each site parameter combo, are just stacked on top of each other. When we look at our low nested data frame, what you see now is that this information is stored within a single column in a bundled data set that lives inside a single column. Pretty nifty, huh? And what that means now is we can actually map over each one of these rows data sets to perform a single function on an entire data set. Another point to just mention is that when you nest data, it will automatically put that nested information in a column called data. But instead of talking about this mapping and how it works, let's actually do it. I think it will be, it'll make more sense perhaps to see it in action here. So what we want to do to just rehash is perform that send slope across each one of these data sets, right? And then get the output or the result of that send slope in its own column linked up to that site characteristic combination. So to do that, we're going to create a new object called water quality models. We start off with our nested data frame. And then here the syntax is a bit of a hybrid of a lot of different things that you've learned that you just haven't really put together. But what we're going to do is create a new column, and we're going to call it our tidy models, or mods, how about, to follow along with the lesson plan. And what that column is going to equal is, and this is where it gets a little strange, but we want to map over our data column, and this is just the same syntax that you're used to with mapping. Across that data column, we want to use our tidier sense function. And then specifically here, this is where you would normally, if you're familiar with how we've been doing things, you do .x of what actually you want to perform the tidier sends on. This is where it gets a little bit different, because what this .x is a nested data frame. So within our data column, we want to perform the send slope on our concentration column. And if you remember to pull a specific column from any data frame, you use the $sign. We want to do this on our concentration column. And now I'm going to run it. And let's look at the results. And what we have here is a new column called tidy mods. If we just kind of follow along down here, what the code actually run to produce this. Within our new column tidy mods, we've iterated over our data column, which is in fact a data frame, and stored that information in a new nested column, because the output is more than just a single row, right? So it automatically is getting nested here. So having it nested like this is cool, I guess, having each one of our model results. But it's kind of, once again, like, that's it. It's kind of cool. It would be more useful, I think, for us to have a data frame that has our basin, our characteristic, perhaps the data stored there, but then just those model results as their own columns to the right of all of this information instead of it being nested. So to do that, we're going to need to unnest our tidy mods column. And it is quite simple to do. I'm going to call this water quality model unnest, and I'm going to make it plural. Okay, so we start off with our water quality models, and then it's as simple as using the function unnest, and then what our column name is that we'd like to unnest. That is called, how do I already forget this? Tidy mods. And because that nested information is consistent across all of these different rows, we have the same column names and so on, we're not going to have any issues with unnesting it. You can almost think of this as a similar but different function as bind rows. But what this will produce for us is exactly what we were looking for, which is that information that used to be contained in its own column, now no longer nested or bundled inside of a tidy mods column, but instead fleshed out in our original data frame. Now that we have each one of our models organized on top of each other in this way, we could perform additional analyses with all of this data. For example, what if we were interested in subsetting this data frame to only locations and ions whose trend through time is in fact significant? We could do that now, starting with this data set. So now you know how to nest, unnest, and perform models using those nested bundles. Congrats!